L'Hopital's rule is used for finding limits in indeterminate form. And a limit in indeterminate form is something like this. When I've got a 0 over 0 or infinity over infinity. So a 0 over 0, let's say I have a problem. Actually, I'll just give an example later for one of these. So let's just go over L'Hopital's rule very quickly. So that's what this top part basically means, as if I have a kind of fraction, let's say f of x over g of x, and both of them go to 0 as x approaches a, or both of them go to infinity as x approaches. That's the wrong color. As x approaches a, then I can use L'Hopital's rule. So if I have these f of x over g of x where they go to infinity or 0, then what I do is I take the derivative of the top and the bottom, and then I can do it again. Take the limit. And if that doesn't work, then I take the derivative again until it works. It's basically how this goes. Just keep taking derivatives. And it does not necessarily have to be an indeterminate form. Actually, I think this is the easiest way to evaluate limits. I always use this method. So let's do an example. Let's suppose I have the limit. No, I don't need a. Let's do 1 of the natural log of x over x minus 1. So using the old methods, there isn't really a good way to evaluate this limit, because as x approaches 1, the natural log of x of 1 is 0, and then this will be a 0 in the denominator, so I'm going to have a 0 over 0 indeterminate form. So what L'Hopital's rule says is I can take the derivative of the top and bottom and then do it again. So I'll do that. So 1 over x, and then this will be 1. And as x approaches 1, this will become 1 over 1, so this limit is equal to 1. So this was an example of a 0 over 0, but it can be used for infinity over infinity, where it's not clear whether there is a limit or not. Sometimes there is a limit, sometimes it goes to infinity, sometimes when the top wins, the limit will go to infinity. If the bottom wins, sometimes it'll go to 0, or there will be some number where they kind of struggle for, and eventually there will be some number that approaches it. But this is what is used to figure out what those limits are. And also it can be used to evaluate regular limits, and the reason why they don't teach this first when people first learn limits is because we don't know about derivatives yet, and to learn about derivatives we have to learn about limits. So we had to do it the other way first before we could learn this easier way, just so we could say, well, here are limits. You need to know about limits in order to know about derivatives. That's the whole reason behind it. So now that we know this, we don't need to do it the other way. We can just use L'Hopital's rule, and it will save a lot of time, because derivatives are generally much quicker than the other method.